All right.
So the first speaker is Vera Hansper from CSC. And Vera is really heroic. She has been moving house the whole weekend, traveling around Finland, carrying washing machines and whatever, and yet she's in shape to give this talk. So.
Barely. Okay, good morning and welcome to Finland for those of you who haven't been to Finland before, and CSC. So my name's Vera Hansper and I'm the manager of the Computing Environments Group, and what we do is provide support to various academic research systems, so including the cloud systems here. Okay, so what I'm going to do is talk a little bit about a background to clouds. This is not, my talk is not meant to be technical. I wanted me to introduce things in a way that would address people who don't have much of a technical idea about clouds. So if you're very technical, you can go to sleep or just smile not knowingly or something like that, okay? So I apologise if anything looks a little bit strange to you on that. So where do we begin? So if you want to think about computing, you could go back in time about wherever. When did computing first begin? When did we first do any sort of calculations? Humans have wanted to do calculations for many years. Probably the first computing tool was the abacus, back before the before the birth of Christ. But PCs, as we know them, first emerged around the 70s. Okay. There was a lot of build-up to that point in computing. There were a lot of mainframe computers. A lot of them ran different operating systems. I think if you go back to around just post-World War II is when computers were starting to come really into their own. But PCs started to emerge around the 70s. IBM was really the precursor of the Microsoft systems, which a lot of people are familiar with as far as desktops go. But Apple was actually before Microsoft, so that was something that surprised me. And if you want to learn a little bit about the timeline of computing, there's a lot of stuff in Wikipedia. So a lot of the information I gleaned for this talk I took from Wikipedia, so just so you know, any errors that I've got are from them as well. Anyway, what's inside a computer? Well, it's really basic. There's a central processing unit, there's memory, known as RAM, and there's some sort of a disk system, okay, so that you can store data and stuff. And they come together in sort of a package, and you access it through a keyboard, and you have a screen to look at what's going on in the computer. Okay? It hasn't changed very much over many decades. I mean, even our systems here are basically that. Okay? Something I want to point out, in my searches for memory, these are ELIXIR-FIs. How about that? So this is an ELIXIR talk, and we actually have an ELIXIR branded RAM. So that's really cute. Anyway, if you were lucky enough in the 70s or the 80s to have access to a network, it wasn't very fast. Baud represents bits per second. So I remember modems of being 300 baud. It was, you could hear the bits coming through the computer and see the bits coming up on the screen. So things weren't quite the way we have them today, but networks were starting to become more elaborate, but still inside they were all the same. A lot of revolutions happened in computing in the 70s, but then into the 80s things really accelerated, and into the 90s. And also in the early 2000s. There's something that's really important though, and that's the influence of free software. I don't think you can really stress enough how much free software has influenced how we do computing today, because without it, we would still be tied to the software or the software and hardware vendors to access computing. Okay? The GNU project was started in about 1983 by a chap called Richard Stallman. It didn't really take off very well, but it wasn't until 1991 that Linus Torvalds, here in Helsinki, at Helsinki University, developed Linux. And once he sent that message to the world through what was they were bulletin boards, so it was the sort of the novice part of the internet. Once he sent that message to the world, to say, I have operating system here, it's like Unix, and I'm happy to share it with anyone, it'll be free, I'd like to have people to help me develop it. A lot of people joined that party. It was amazing how many people joined that party. I had colleagues in my office who were right on the bandwagon when the first distributions came out in '92. And I was using Linux back in '92. That was so much fun to be able to finally have an operating system which made a bit of sense rather than Microsoft DOS. But there is a lot to be said for the value of free software. We didn't just have the software revolution, we also had technology revolutions in hardware and networking. 300 bits per second. You wouldn't be able to stream a video at that rate. It would take you years. I don't know, I didn't do the calculations, but it would take you a long time. No one would do that. So now we're talking around gigabits of streaming, like your 10 gigabit network is more or less standard in the academic research world, and they're trying to put it into some more public commercial space, but they became faster. And that improved also. All the revolutions in hardware, the network, also improved the revolutions internally in how the processors communicated with the hardware inside the system. Because software was free in the sense of what Linus had sort of exploded onto our world, a lot of the development became easier for people, so there was a lot of development speed up. And hardware, well, there was definitely an improvement with hardware over time. So hardware became more affordable for the average person. Back in the 70s, very few people would have owned a PC. In the 80s, there were hobbyist-type PCs coming out. So people might remember quite lovingly a Commodore 64, or my brother had something called a Micro B. These were things that were running on a very basic 8086 processor. So those things were very simple, but that speed of development, where you ended up having faster computers, faster memory, faster disk access, and faster network, meant that we ended up having things like the birth of the internet around the mid-90s, and we had better ways of doing things with the computers. There wasn't just Linus who did something amazing with free software. There were other developments in hardware which also revolutionised the way we use our computers now. And a lot of it comes down to what are we paying for what we have. So Intel dominated the sort of commodity, I suppose, CPU architecture for a long time. But because of various legal things, AMD came into the play for producing CPUs. Now, there was some legal wrangle, and again, read the stuff on Wikipedia, because I don't have time to go through that. But because of that, we ended up having very affordable CPUs, 64-bit CPUs that worked. Intel brought out a 64-bit compute or chip in about '99, which was a flop, but AMD brought out one which wasn't. And we had the birth of multicores. So suddenly we had computing power that was equivalent to what the mainframes had, we had better hardware, and we had multicores. So you could finally extend all your calculations to a larger number, so 2 to the power of 64. So that's also the memory bus address, so if you like. And what also happened was that the commercial Unix flavors started to diminish. This is around the 2000s. And Linux started to dominate. And things like Linux meant that, and because of the hardware, you saw a sort of a dearth in the monolithic Unix supercomputers that the big vendors have, like IBM. So those big mainframe computers, which still exist somewhere in the commercial world, didn't exist so much in the research academic world anymore. Supercomputers were starting to run Linux. And then we ended up having things like the cloud. Okay, from all of that came out that you had nice fast interconnects for the processors. So the processors could communicate between each other through the network. They could communicate between the various computers, and people built up virtual machines, and they built up clouds. So this is what cloud architecture looks like. And maybe someone around here is going to tell you a little bit about it, but I just want to show you that because it looks really complex. And, you know, what most people see is this part. They have no idea about this part behind that the cloud sits on. Okay. And I think if you didn't have what we had in the revolution in software and hardware, we'd probably still be at just that part there. We wouldn't have this big complexity. But, you know, you can only say that with foresight or with hindsight, because you don't really know what would have happened if we didn't have those revolutions. Cloud started off around the early 2000s, and there were commercial providers like Yahoo and Google who provided mail, usually sort of a free mail service, but this was already mail in a cloud environment. You didn't know where your mail sat. It was somewhere there on the internet. Okay? So they were conceptually clouds already in the early 2000s. In the mid-2000s, around 2006, Amazon started selling off its excess compute cloud cycles as a cloud service. And people were getting very excited about that at that time. Microsoft, in a couple of years later, Microsoft also created its Azure cloud environment, and they were also trying to get people to come onto that cloud bandwagon. But because Amazon was there first, people were very used to what Amazon provided, and they all thought, oh, this is great, because now I don't need my computer anymore, I can just use the cloud. These systems were easily accessible to the average person, and I think that was very important at the time. Where we are today, though, is that we have not just one or two clouds, we have multiple cloud services. We still have Yahoo and Azure, and we have Google providing cloud services, but we have a lot of research cloud services, and some of them are connected to each other, okay, and some of them aren't. Some might be completely isolated, so there might be a commercial cloud doesn't have access to a research cloud, for instance. And the beauty of today's systems is because we have open source and free software, those cloud concepts are easily accessible for organisations like CSC to provide a cloud infrastructure. Okay, I don't really have that much time, so I'm going to have to skip through the last bits. I just wanted to say something about the pros and cons of clouds. Commercial clouds. They're very easily accessible, and they give opportunities for people to collaborate across academic or national boundaries. Okay? What the problems with commercial clouds is they can become expensive very quickly. Anyone who has really looked at what they need in a commercial cloud and looked at the cost of it will find that it's quite expensive. So there are many hidden costs. There's no software support, and there's no guarantee that what that instance that you raise in the commercial cloud is going to be available later on. So, and then academic research clouds. Well, one, again, it's that word there, free. That is, I think, the thing that drives our innovation, because it's readily available and it's accessible to people. Software is generally supported, and your instance, when you run a calculation in a research or academic cloud, it is more or less guaranteed. Okay? In fact, I know that for most research organisations, if your instance dies for whatever reason, they will resurrect it for you and try to get you going so that you can finish your research. That's very important to a researcher. The downside is that it can sometimes be difficult to access because there are certain rules around how you access a research cloud. And because of that, it can also be awkward to do international collaboration. There are things like the European Open Science Cloud, which are trying to address those issues, and even ELIXIR is trying to address those issues by creating a more collaborative cloud environment between various ELIXIR nodes. And even nationally and internationally, CSC is involved with providing a cloud service that can cross the boundaries into the rest of the Nordic countries. So, you know, we have ways of getting around that, but it requires some more work. So, what should you use? If you are doing academic research and you need guaranteed, well, if you need your guaranteed performance, have long calculations, or need support with anything, which is probably for most researchers, then an academic research cloud is the way you need to go. There's really no doubt that you're going to get the best what you need from a cloud if you use the research clouds. However, if you just want to test the functionality and you have no storage or minimal storage and minimal data transfer requests, so minimal network access, or you need to run a small urgent job, then a commercial cloud is probably a good thing to do just for a spot instance to get something done very quickly, and you don't have time to go through the allocation or application thing like that, so you can do that. It'll cost you something, but you can do it. And also, if you don't have an affiliation with a research cloud provider, then unfortunately that's the way you'd have to go. So that is sort of like the bottom line. If you are a researcher, your best bet is to go with a research cloud. So I've already gone over my 10 minutes, but that's just a partial list of the references that I've used, and particularly any searches including terms like computers, history, and cloud. So if you want to, you're more than welcome to do your own history reference in that. I found it very interesting looking at some of the history. There was stuff that I didn't even know at the time. So thank you.